Okay, let's have a look at the question.
Write a program to find the GCD of given two numbers. Yes, how we are going to find out the GCD? Yes, guys, how we are going to find out the GCD? Yes, very good. Through recursion. Yes, first we'll check out what is GCD. That is important, right? First, we need to know what do you mean by GCD. Can I say GCD is nothing but the highest common factor or greatest common divisor? GCD stands for greatest common divisor or the highest common factor. I can say it is nothing but the HCF. Okay, I can say it is nothing but HCF. So how we are going to find out this GCD here? Okay, there are different ways to find out the GCD. So let us assume like if I'm going to take out to 18 and 24, 18 and 24. What is the GCD of this? Here I can say GCD is 6. GCD is 6. Yes, how we are going to check it out? How we are going to check this? Yes, one thing is like in general, what we are going to do is we'll be having 18, we'll be having 24, we'll be checking out with the number which is like which are the factors of it. So it will be 1, it will be 2, it will be 3, 6, 9 and 18. Similarly, I'll be going with 1, 2, 3, 4, 6, 8, 12 and 24, right? GCD is nothing but the highest common factor or the greatest common divisor. These are the divisors. So you have to find out greatest. 24 is not there, 12 is not there, 8 is not there, 6. Yes, this is the answer here. This is the answer. Now, first thing what you have to do is this is the one type, okay? One type where we'll be going with this one. This is type 1, I can say. Type 1. Yes, other thing. Yes, we can go with recursion also. We can go with recursion. How? Whatever the GCD or whatever the number we have got here, we'll be taking out the modulus here. Taking out the modulus of those numbers and we'll be taking out the remainder as well as the other one. Getting it? Take out the division. What is the remainder? Take out the remainder as well as the other number there. Okay. Until and unless you make the other number equals to 0. Until and unless you make the other number equals to 0, other number equals to the given number here. So what I can do is I can say GCD is the function where I'll be sending N1 and N2. Please make a note of it, N1 and N2. Inside this, what I'm going to check is I'll try to make this as 0. If N2 is not equals to 0, if N2 not equals to 0, then what I'll return here is I will return, I will return GCD of, I'm calling the function once again, GCD of what? This number, GCD of the next number n2 in which you are dividing n2 and n1 modulus n2, n1 modulus n2. So you will be taking out the remainder again and again, again and again, and you will be swapping the numbers here and there. Else, else, if it is n2 is equals to 0, of course we have to return n1. So we have to return n1 value at last. Okay, this is type 2. This is type 2 to find GCD. Yes, any other way? Yes, any other way? Sorry. Yes, guys, try to understand this. We'll try to understand different ways so that it will be easy for us to answer. Okay. This is by using division. This is by using modulus. Yes, any other way? Yes, very good. We can go with Euclid's algorithm. That is nothing but subtraction, right? Yes, very good, Pushkar. We can go with subtraction also. So we can say int GCD. We are calling a function GCD and we are going to send N1 and N2. I'm taking the same numbers here, N1 and N2, and inside which I can go with either while loop or for loop. I'll take out while until and unless you're going to get these two numbers greater. Okay, while N1 is greater than N2, while N1 is greater than N2, N1 is greater than N2, we have to take out A equals to, sorry, N1 equals to N1 minus N2. N1 equals to N1 minus N2. So we'll be keep on running that while loop. Okay, for a clear thing, I'll just write the code clearly over here. If you're going to get this one, so first you have to check out with N1 equals to 0. So if I'm going to say if N1 equals to 0, then I'm going to give return N1, return N2, because N1 is 0 there. Okay, return N2. Next, if this is not the case, while I'll be running this, while N2 is not equals to 0, inside which I'm going to take if N1 is greater than N2, then I'll be taking out N1 equals to N1 minus N2. N1 minus N2. Else I'll be taking N2 equals to N2 minus N1. And at last I'll be returning N1. Return N1. So this will be the case of subtraction. This will be the case of subtraction. Okay. So instead of understanding in terms of like yes, using Euclid's algorithm or something, you can understand with respect to subtraction. Yes, there are other ways also to find out the answer with the help of the normal subtraction. You can go with that also without using while loop. Without using while loop, where you have to take out the modulus also. Getting it? So we'll be taking out, yes, we can use recursion in subtraction like how we have done it over here. N1 modulus N2. We can go with N1 minus N2 comma B. That is nothing but N2. So we can go in that format also. Okay. There are different ways. So we'll try to understand this GCD in one by one step. Okay. We'll try to execute the code in one by one step. Yes. Any doubts in this part, please ask. Any doubts in the theoretical part, please ask, guys. So we'll try to go with at least 2 to 3 different types so that it will be easy for you. Yes, any doubts in this? So please explain recursion method. Yes, in this recursion method, I'll just go with one example that will be more clear, I think. So let us assume like I'm going with 18 and 24 here. Okay, 18 and 24. This is 18 and this is 24. So what I'll be checking is whether I'm checking whether this 24 is equals to 0 or not. No, it is not equals to 0. If that is not equals to 0, what I'm returning is I'm calling the GCD of 24. 24 is over here. 24 comma 18 modulus 24. What is 18 modulus 24? What is the remainder when you are going to divide 18 by 24? It's 18 itself, right? 18 itself. Now what happened here? Here the number has been swapped. Right? I can see the number has been swapped. But when the number will be swapped, if the first number is smaller, at that time the number will get swapped. Again, you're calling this, again this, look here, this second number is getting reduced from 24. It has become 18 now. Okay. Now again, you're going to check out with this. You're going to call the GCD of 18 comes here, 18, comma 24 modulus 18. What is this 24 modulus 18? When you're going to divide 24 by 18, you will left out with remainder 6. Now we have got 18 and 6. 18 and 6. Okay, next when you're going to call the GCD, this 6 will come over here, and 18 divided by 6, what is the remainder? Remainder is 0. So when you get this 0 here, when you get this n2 equals to 0, you will be returning n1. You will be returning this number, that is nothing but 6. GCD of that number will be equals to 6. Is it clear? In the same step, if you're going to get any number which is greater than the other, of course it will replace or it will swap those things in the function itself. Is it clear, Gayatri? Is it clear? Okay, fine. Then I'll move to the programming part so that it will be easy for you guys. So I'll go one by one. Okay, type 1, type 2, and type 3. So whichever you want, you can go with this type 1, type 2, or type 3. It's up to you. Okay. So I'll go with a normal thing. That is nothing but by checking out the highest common factor. The second one, I'll go with recursion, and third one, we'll go with recursion along with subtraction. Okay. Please make a note of all the types. Any doubts you have, please feel free to ask. So if I want to find out the GCD, of course, I need to scan the two numbers first. So I'll first define it n1 comma n2, and I'll be scanning the numbers here. Scanf percentage d. Percentage d is for the integer type. So I'll be taking out percentage d and percentage d because I need to scan two numbers, and it will be stored in address of the first one and the address of second one. Okay. You have to store it in address, right? It will be stored in address of first one and as well as the second one. So scanning is done. So we have already taken the input. So after taking out the input, what we have to do? We need to take out the numbers, right? Yes, please look into this. I'm writing the type 1 here, okay? I'm writing the type 1. I have taken example of 18 and 24. 18, what are the factors? It starts with 1, 2, next number is 3, 6, and 9, and 18. Similarly, for 24, we have 1, 2, 3, 4, 6, 8, 12, and 24, right? Now, if you're going to start from the bottom one, please understand, you have to check out whether 1 is divisible by both the numbers or not. Yes, of course. Next, you'll be checking with 2. Next, you'll be checking with 3. Next, you'll be checking with 4. Similarly, you'll be moving from 1 to N1 or N2. Okay, you can go with till there. You can go till there. But instead of going till there, what you have to do is here you need to keep on updating the numbers, right? You will get the first number, 1 is divisible. Next, you will be checking with the 2. That is also divisible. It means you need to update the GCD there. You need to update the HCF. So HCF says highest common factor or the greatest common divisor. So instead of going with this, what we'll do is we'll move from the last. We'll move from this direction. If you get any number which is common, that will be the greatest common divisor, right? So I can start with 18 or I can start with 24. But we already know that the GCD will never be more than the smaller number given there, right? It cannot be more than 18 if I'm going to have a GCD of 18 and 24, right? So what I have to do is first I need to check which is the smaller number. First I'll check which is the smaller number and I'll proceed from there. Okay, so I'll check with 18, not divisible by 24. Next 17, 16. Similarly, when you get to know, so here in this thing I have common factor 6. From the last, that's the first common factor. So whichever the common factor you're going to get, that will be your answer. That's the first type. This is type 1. So what I have to do? From this we got to know that instead of moving from for I equals to 0 or I equals to 1 to n, we are moving from back. So for that, what I have told, we need to find out the small number here, right? What is the small number? That is important. So for that, I will write one small code here. First, find out what is small. Which number is small? I'll take out small equals to, I'm giving the condition here, okay? N1 greater than N2. If N1 is greater than N2, this is the condition. I'm checking out N1 is greater than N2. If N1 is greater, then what should I get the answer? I need to get the answer as N2, right? Or else you can go with if N1 is less than N2. Anyways, is okay. You have to find out the lesser number. If N1 is less, I will return N1 or else I'll return N2. Or else I'll return N2. This is small. So we have taken the small value. I'll just give out int also here. Okay, now I got to know what is the smaller number, 18 or 24, whatever it is. Now what I have to do, I need to run a for loop for I equals to, I need to start from smaller number, I equals to small, I greater than or equals to 1. I need to move up to 1 because if no numbers are there, then of course first number or 1 will be divisible by both the things, right? I minus minus. I equals to small, I greater than or equals to 1, I minus minus. Next, after that, what we have to do? Yes, we have to check with this thing. If n1 modulus I equals to 0 and n2 modulus I equals to 0. If both the cases satisfied, then I can say that will be the answer. That will be the answer. So at last it will get satisfied for 1. So I'll be going out with this. If n1 modulus I equals to 0 and you have to give and, okay, and n2 modulus I equals to 0. This equals to 0 says if it is divisible or not. If it is divisible, then I'll be going out with printing number. I need not update anything. Okay, printf %d I need to print I. I need to print I because that will be the GCD. Once you have received it, we don't want anything else. I'll just give out a break, which will come out of the for loop and it will end the program. Here, this is type 1. Yes, we'll try with some of the inputs here. We'll try with some of the inputs. Yes, I'll take out 8 and sorry, I'll take out 18 and 24 itself. 18 and 24. Answer should be 6, right? Yes, we have not defined I here. I'll just take out int I itself. Is anything else here? I is undeclared. Okay, that's the only one which is undeclared. Yes, we have got the answer as 18. Okay. Okay, look here. I have made one small mistake here. It should be n2 modulus I. So be careful with that because finding out I and 1 will be difficult. And 1 and L will also be difficult. So you need to be careful with that. Yes, here we got to know the answer is 6. Is it clear? Is it clear? I'll take out some prime number here because the values will not be HCF will be or GCD will be equals to 1 itself. I'll check out with 13 and 7. Both are prime. So the answer should be 1 here. Okay. Is it fine? So this is with respect to this, right? So what I'll do is I'll just take this out in a comment section. Okay. Now I have taken this in comment section. This is one part. Okay. Now I'll write a program for recursion. This is the first type. Okay. Now we'll go to the program for recursion. How it is going to work out. So any doubts in this part, please ask. Any doubts in this? Yes, guys, any doubts in this? Please ask. Hello. Okay, good. Now I'll move on to the recursion. Okay, I'm writing the program in the same page. Don't get confused with this. Okay, so this talks about the comment line. It's a comment line for the multiple one. So don't take anything within this. Don't take anything within this. Now I'm writing the same code. From here, I have scanned two numbers. After that, I'll move on with the recursion. That is nothing but calling the function again and again. So before that, what we have to write? We have to get the GCD of two numbers, right? So I will write down printf, the value should be percentage D. The value should be percentage D. And what is that percentage D? It is nothing but GCD of, it is nothing but GCD of A comma B, or I can say N1 comma N2. N1 comma N2. Now I have forwarded this number to a function called as GCD, to a function called as GCD. Now I need to write the function GCD here. Okay. So I will take out int GCD because I need to send the number here, and I'll be taking out int N1 comma int N2. Int N2. So inside this, what is the first case? I'll be taking if N2 is not equals to 0. Similarly, you can go with N1 not equals to 0 also. If N2 not equals to 0, then we'll be returning, sorry, caps lock was on. Okay, we will return, yes, what is it? If N1 not equals to 0, then what we have to return? We have to return N2 comma N1 modulus M2. N1 modulus N2. We will be returning GCD of N2 comma N1 modulus N2. Else what is the case? Else we have to return, if N1 is equals to 0, then we have to return N2. Else we will return N2. Sorry, N2 is N1 equals to 0, right? Here I have taken N1 equals to 0. So I'll take out N2 equals to 0 here because I have taken N2 comma N1 modulus N2. Then we have to print N1 in this case. Yes, we'll try checking out the numbers here. So at last N1 will be the answer. Yes, I'll go out with 13 and 7 first. Yes, we have got the answer as 1. Next, I'll go with other numbers. That's nothing but 18 and 24. Yes, we have got the answer as 6. All right, any doubts in this, please ask. Any doubts in this case, please ask. So don't write anything which is there in this section. Other than this, write it. This is using recursion. Recursion, what we are going to do? We are calling a function, and inside the function, we are calling another function once again. Function call under a function call. Clear? Instead of this, what we can do is we can go with subtraction also. Okay, through subtraction, GCD through subtraction, we can go with that also. Yes, if you are okay with these two techniques, that will be more than enough. Because this recursion with modulus will be a little bit easy when compared to subtraction, because subtraction and modulus also work similar. So you can go with any one of the things. Okay, try to understand this one or the other one. This is one program, and this is the other one. Yes, you can take any one of this. This is using recursion, and this is using a normal for loop. Is it clear, guys? Any doubts in this, please ask. Any doubts in this, please ask. Yes, if you want to go with the other part, that is nothing but recursion through subtraction. So I'll write down this code, okay? This is nothing but GCD of n1 int n1 comma int n2. So if you want to go with recursion through subtraction, so what you have to do is first you have to make the GCD equals to 0, inside which you have to give int GCD equals to 0. First make GCD equals to 0. From there you have to update it. Okay, so if a is less than 0, because there is sometimes when you're going to subtract it, the value of a might fall to negative. So finding out negative of the value will, or negative GCD will be difficult, right? So what we have to do is we have to make it positive. I'll take it out. If a is less than 0, I'll take it out. A equals to minus a. Similarly, if b is less than 0, then I'll be returning b equals to minus b. B equals to minus b. Then what is the next case? If a equals to b, then we will be giving out the GCD, that is nothing but return a here. We'll be directly returning the value return a. So no need to give this GCD once again here. We can just get the values. Okay, you have to return a. But what is the function? What is the function you are going to give? If you're going to know if a equals to b, yes, done. We have gone with the other values also. Now, if a is less than b, or if a is greater than b, else if a is greater than b, what we have to do is when it is greater, I need to return the GCD of, if a is greater, you have to subtract b from it. A minus b comma b. Okay, else it will be greater, so you have to return the opposite one. That is nothing but return GCD of a comma b minus a. This will be the GCD function here for subtraction. A recursion using subtraction. This is a normal common multiple. Okay, finding highest common multiple. Okay, highest common multiple, sorry, highest common factor, right? Highest common factor using for loop. Using for loop. This is a recursion using modulus. Okay, so I have given all the three types. So whichever you want, you can go with it. Okay, guys, thanks for watching. And for more updates on similar videos, don't forget to subscribe my YouTube channel. Thank you.